Hello class! This lesson will be looking at exponential equations. So the goal is to use equality of powers with a common base to solve exponential equations. When solving equations, we use different methods depending on the type of equation. We have already looked at solving linear equations and solving quadratic equations. But if x is in the exponent, then we are solving exponential equations and require a different method to solve. We will be solving all exponential equations by using the following fact. If b of x equals b of y, then x equals y. This fact only works if the bases are the same. So if we look at our first example, 3 to the power of x plus 1 equals 3 to the power of 4. Our x is in the exponent, and our bases are 3 and 3. So we could use the above property to solve for x. But here, 5 to the power of x minus 9 and 2 to the power of 2, x is in the exponent, but our bases are different, so we can't use this method to solve. So let's look at an example. So we're going to solve for x and check. So we have 5 to the power of 3dx equals 5 to the power of 7x minus 2. First thing to realize is that x is in the exponent, so we're solving exponential equations. So next is to see if we have the same base. In this case we do. Same base. So we can use the above property where we can set our exponents to each other. So 3 to the x equals 7 to the x minus 2. Now we just go about solving for x. So we collect like terms. So we bring the x's to the same side. 3x minus 7x equals negative 2. Then we simplify. 3x minus 7x is negative 4x equals negative 2. Divide by negative 4. X equals positive 1/2. So if we checked our answer, left side, right side, left side, 5 to the power of 3x, right side, 5 to the power of 7x minus 2. We substitute our answer, x equals 1/2 to each. Five times 1/2, 1.5. 7 times 1/2, 3.5 minus 2. 3.5 subtract 2. It's 1.5. Therefore, left side equals right side. Our answer is correct for x to equal 1/2. Let's try a second example. So we have 3x equals 9 to the power of x plus 5. So first thing we notice that we have x in the exponent, so this is an exponential equation that we're solving for. And then we want to see if we can use our property. But we don't automatically have the same base. What we want to consider here is, can we make the same bases? Can 9 be rewritten as base 3? And using our power rules, we can. So I have attached on the D2L a table of powers. And we can use that here to see if 9 can be written in power of 3. So in the base 3, sorry. So if we look at this, our columns are our bases, and our rows on top are our exponents. So we're looking for 9, which we have here. So we know 9 going across to its base can be written base 3. And we know that exponent, in order to get that, would be 2. So 3 to the power of 2 will get us 9. So let's make a note of that here. Nine equals 3 to the power of 2. So because 9 can be written in terms of base 3, we can actually change it. So we can rewrite our base 9 to 3 to base 2, 3 to the exponent 2 to the power of x plus 5. So let's note here different bases need to, different bases need to be made the same. And we do that here, looking at our chart, as well as rewriting it. Now this is where we use our exponent laws. We have a power to a power, which is multiplication. So this 2 gets multiplied to both terms, like distributive property. So 2 to the power of x is 2x. 2 times 5 is 10. So now that we have the same base, we can equate our exponents. So now we can let x equal 2x plus 10. Collect like terms. Bring the x's to the same side. We're left with negative x equals 10. We always want positive x. Divide by negative 1. Therefore, x equals negative 10. Okay, let's flip our page. I have mine here. Okay, let's look at this example. 8 to the power of 2x plus 6 equals 1. We notice that x is in the exponent. So we're dealing with exponential equations. We're trying to find afterwards the same base, but we notice again, bases are different. We have 8 and 1. But what do we need to remember? 1 can always be written in terms of x to the power of 0 equals 1. So let me make a note of that. Remember, x to the power of 0 equals 1, meaning that any base to the power of 0 is 1. So in this case, since our base is 8, we can just rewrite this as x to the power of 0 equals 1. So we can rewrite this x to the power of 0. Now we have the same bases. So we can equate the exponents. 2x plus 6 equals 0. Collect like terms. (2x equals negative 6) divide by 2. X equals negative 3. So if we tested that, 2 times 3 is 6. Sorry, 2 times negative 3 is negative 6. Plus 6 is 0. 8 to the power of 0 is just 1. So one more example. 9 to the power of x plus 1 equals 27 to the power of x. X is in the exponent. We want the same base. We don't have the same base. Can 9 and 27 be rewritten in the same base? Let's take a look at our chart. So we're looking for 9. We know 9 can be written in base 3. And look at that. 27 can also be rewritten in base 3. So 3 to the power of 2 equals 9. 3 to the power of 3 equals 27. So let's make note. So we know 9 equals 3 to the power of 2. And we know that 27 equals 3 to the power of 3. So we can rewrite our bases in terms of the same base that we know. So 3 to the power of 2 equals 9. X to the power of 1 equals 3 to the power of 3, all to the power of x. Exponent laws, power to a power, we multiply. 2x plus 2 equals 3 to the power of 3x. Now we have the same base, so we can equate exponents. So we can set 2x plus 2 equaling to 3x. Collect like terms. 2x minus 3x minus 2. So I brought this to this side. The constant to the left side. Sorry, to the right side. 2 subtract 3x is 1x. Negative 2 divide by 1. Negative 1, I should say. X equals positive 2 as our answer.